Hi, I'm Royce.
And I'm Cole, and we're both juniors at Cathedral Catholic High School in Del Mar. This year, we both took AP Chemistry, and we learned a lot of new and interesting concepts and ideas.
Today, we would like to demonstrate what we have learned in an experiment, and the best part about this experiment is that it includes you.
That's right, we want you to follow along. Perhaps you'll learn something today and be able to do this experiment on your own sometime soon.
Today, you will specifically focus on two of our favorite concepts from our AP Chemistry class. One, the interrelation of temperature, pressure, and volume, and two, acid-base neutralization.
We began our year in AP Chemistry learning about how molecules, which are tiny particles that construct everything, react when one of three different variables changes. These variables are temperature, which is the change in heat, pressure, which is the force exerted by molecules, and volume, which is an object's capacity. Each of these variables, when changed, affects at least one of the other two variables.
In addition, we also learned about acids and bases and their interactions when they're both dissolved into each other. An acid is a substance that is sour and reacts with a base to produce water and a salt. A base is a substance that is bitter and reacts with acids to produce water and salt as well. You could think of an acid as a positive or plus sign and a base as a negative or minus sign. When an acid and a base come together, they cancel each other out, just like plus and minus cancel each other out. The only thing left is water, and the byproduct, or what's left over of the reaction.
Experiments are no fun if somebody gets hurt, so be careful and pay attention to these safety rules. First, you should always wear your goggles in the lab. Goggles protect against chemical splashes and projectiles. You should also never touch any of the chemicals with your bare hands unless a knowledgeable adult deems it safe to do so. If you get any chemicals on your hands or other body parts, immediately wash the substance off and alert a teacher. If a chemical spills, stay away and tell a teacher so they can come and clean it up.
Today, we will also be working with open flame. Fire can be very dangerous if not dealt with carefully, so it is important that you listen to these rules about fire safety. First, never leave the room if there is an open flame in use. Always tie back long hair and pull back loose articles of clothing. Know where the fire extinguisher is or another firefighting agent.
This first experiment involves acids and bases. In this experiment, we will need one empty 1-liter bottle, one uninflated balloon, one small funnel, at least 2 tablespoons of baking soda, and at least 4 ounces of vinegar.
After putting baking soda in the balloon using the funnel and putting the vinegar in the 1-liter bottle, we are prepared for the experiment. Before attempting the experiment, I'll explain how the reaction will work. Listen closely so that you know what is happening as it occurs. While keeping the balloon upside down so that the baking soda doesn't fall out, we will attach the balloon to the opening of the bottle. We will let the balloon hang on the outside upside down until we are ready to start the experiment.
Once we're ready to start the experiment, we will turn the balloon upside down and move it around a little to make sure that all the baking soda falls into the bottle. As soon as the baking soda touches the vinegar, you will see a really cool reaction start to take place. First, the mixture will begin to bubble violently. Then, you will notice the balloon will start to inflate. These are both signs that a reaction has taken or is taking place.
The reaction involving vinegar, an acid, and baking soda, a base, forms carbon dioxide and water as a byproduct. You don't need to know what any of that means, other than that the thing that makes the balloon bigger is a gas that is filling the entire bottle. Don't worry if you don't understand just yet. After we do this experiment in reality, you will be able to better see what happens and why.
Now you see Royce and Cole placing 2 tablespoons of baking soda into the balloon to set up the acid-base neutralization of the baking soda and the vinegar that they have set up in the prior scenes. Now you see Cole and Royce taking the measurement device and placing 4 tablespoons of vinegar into this device and then placing that into the container so that the reaction can occur.
Some of it did.
Okay, so now you put the excess in with the rest. Alright, so that's about 4 tablespoons.
Yep.
More.
No. So
Alright,
that's 4 tablespoons of vinegar
and 2 tablespoons of
baking soda in a balloon.
In a balloon.
Okay.
So now, now we put the balloon over the surface of the bottle.
And make sure this is centrally located.
Yep, and we want to make sure it's over our towels.
Yeah.
And you want to make sure you hold it up because otherwise it's going to fall. Okay, so now for our reaction, we pour it all in. Make sure you hold it up and move it around
Hold the
a little
seal.
bit.
Make
Hold
sure
the
it's
seal.
sealed. Make sure you tap on the balloon and make sure all the baking soda is in.
You probably should have
Then hold it up.
this.
Yeah. Just hold
All right, so this reaction produced exactly this much carbon dioxide, and what's left in here is a mixture of water and maybe a little bit of vinegar and a little bit of baking soda, but mostly it's water. Okay, so now when you're done, carefully remove the balloon from the if it allows you. First, you want to try?
Yeah.
It's stuck on there. There we go. See? And all the carbon dioxide is now up. Now that we have finished this reaction, we need to make any final observations about appearance and any other characteristics that are different from when we started. Make sure that everything is cleaned thoroughly and in a safe manner.
Yes. It is just as important to clean up safely as it is to prepare for and conduct an experiment safely.
To properly clean up this experiment, we disconnected the balloon from the bottle, letting all the gas release into the atmosphere. Once this was completed, we could dispose of the balloon in the nearest trash can.
Next, we can drain the remaining vinegar and baking soda in solution with the water in the bottle. Since this isn't a toxic mixture, it can go down the regular drain. However, if we were dealing with substances that are known to cause toxic reactions, or are toxic themselves, we would need to place them in a specified container provided by the teacher.
When anything goes down the drain, it eventually ends up back in our environment. It is important that we keep our environment in mind when we are cleaning up after our chemical reactions. Otherwise, someday we might not have an environment to care for.
I hope you enjoyed this experiment because it's time for the next one. In the second experiment for the day, we will be observing the effects that temperature change can have on the pressure of a fixed quantity of air in a malleable or changeable container. In other words, we will be watching as temperature changes the size of balloons.
In this experiment, there are some things to keep in mind. First of all, we always need to have our goggles on when performing a lab experiment. In this experiment, there will be an open flame and hot objects. It is important to remember that many objects look the same no matter if they are hot or cold. Never feel an object with your bare hands to test if it is hot. You can burn yourself badly if you unknowingly touch something that's hot. Instead, hold your hand close enough to the object that you can sense whether it's hot or cold.
If you or a classmate burn yourself, alert a fellow classmate, or better yet, the teacher. Proceed to apply cool water to the site of the burn. If we all follow the safety instructions, however, there will be no need for an emergency protocol.
Now, to talk a little bit about the background of this experiment. Materials we will need include 3 balloons that can be the same type as the one from the previous experiment, a pot, tap water, a source of fire or another heated surface, a freezer, and a 1-liter glass bottle.
We will begin the experiment by blowing the 3 balloons up to about halfway. This means you should only blow up the balloons about halfway, and their sizes should be about the same. After blowing up the balloons, put them to the side. Next, fill the pot with water and put it over the source of flame or heat. It could be a stove or a layer. Put the 1 liter bottle in the water and attach one of the balloons to the top of the bottle.
Make sure that when you are attaching the balloon to the bottle, you lose as little air as possible. If you lose too much, you can always blow it back up to a similar size to the other balloons. Once it is attached to the bottle, hold the bottle down in the water as it heats up. But be careful not to touch the water.
As for the other balloons, put one of them into the freezer. Keep the other one as a control, which means that nothing will change about this balloon so that we can compare it to the other balloons after their changes occur.
Now we can start the experiment for real. Remember to take avid notes about your observations, look for things and how they change in shape. Blowing up balloons now. We're going to blow 2 up, tie them. One is for the fridge, one is for the counter as a control, and then the other balloon we're going to wait to blow it up in the pot. Okay? Royce? Oh, you can't?
Well, let me try.
Well, yeah.
Well, how do you blow? You know what, you do it.
I'll just get a new balloon. Yeah.
I don't know. I can never blow up balloons.
I can never tie them.
See? Both of our skills combined. We could be.
Can you tie them?
No.
How are you even supposed to? Oh, I think that's. Okay, here's one. You've got to compare them, see if they're roughly the same size. And here's the second one.
Okay.
All right, now, as for the third one,
You want to move over to the stove?
we are going to move over to the stove. All right, so wait 1 second. So Royce is now pouring some of the water from the tap. Be careful, if it spills, just get the towel. So he's just going to pour it in so that it covers the bottom of the pot,
Do you think that's enough?
but not so much that it floats the flask.
Is that-
That's enough, yeah,
okay.
as long as it covers the bottom.
Okay.
All right. Now Royce is going to turn on the heat.
Which one? This one? Where should I put it to?
You turn to the right.
Yeah, about like how much?
Like all
That's
the way. Like, I don't know.
That's fine.
Yeah, that's probably good.
Okay. So
Alright.
Paul, what Cole's gonna do now is he's gonna blow up the balloon again, the third balloon. He's gonna blow it up to be a little bigger than the other ones because he's gonna have to put it over the glass flask so some air will escape. And there. The heat's on as well.
So then just keep filming so that they can see how big it gets.
Is it getting any bigger?
The balloon has to be like securely on, otherwise it
Yeah.
will like fly off.
Yeah. And what's supposed to happen is it's supposed to get bigger.
Then you hear, zoom in right here, you can see the vapor inside from the air pressure.
You can see, I don't know if you can
starting
see
to
here.
bubble. The
but
water
there-
itself is starting to bubble, so you know you're at boiling point.
So there's some condensation, you can see it. You can see the water starting to bubble, so it's at boiling point. You notice the balloon seems to be getting bigger.
Don't touch the pot, obviously, tell them that. Tell them to be careful. And see, it's bubbling, it's boiling now. And the balloon is getting bigger. You can compare it to this one. It's much bigger.
Mm-hmm. And that's the control balloon right there on the left. And the balloon seems to be about getting slightly bigger, about the same size. I think we should stop.
Alright, so now we can turn off the heat. and carefully, with a set of heat gloves or another heat item, try to remove the bottle from the water and place it on the counter for observation. So here's the balloon that's supposed to go in the freezer. As you can see, it's the same size as the control balloon right now, and it's although this has shrunk a little bit, it's still smaller than what this balloon was, the heat balloon.
The heat balloon.
So now we're going to put this in our freezer and make some room. Alright, so there it goes.
Even though there were no chemicals involved in this experiment, it is still just as important to carefully clean up and leave the lab as we found it.
Start by taking the bottle out of the water and the balloon off the top of the bottle. Throw the balloon in the trash and put the bottle in the sink. Next, throw away the balloon from the freezer and the control balloon. Empty the pot of water.
Make sure to listen to teacher directions, because they might want you to do something a little bit differently. Always listen to your teacher, no matter what the directions say.
Now that we're done with the experiment, we are clear to take off our goggles. Now it's 5 minutes. All right. Today we've learned a lot. Let's go over some of what we've learned. First, we learned that when you combine an acid and a base, they cancel each other out and form water, and in this case, carbon dioxide.
Then, we learned that a change in temperature means a change in volume because of a change in pressure. These basic principles of science are true everywhere in the world. Scientists today use these principles to understand the world around them and to interpret the experiments they perform in their own labs.
Science can be a great tool to understand the world we live in, and you can make a difference in the science of the future.